Hello, I am Fish. I will be submitting a hybrid into the Aquatic Hybrid War by Goji Guy. This is going to be my submission. My hybrid is O-5 Nyx. The O-5 is the designation number. This is the 5th iteration of the Nyx genome, if you will. So, getting into what I'll be going over genetic contributors, physical characteristics, combat capabilities, special traits, mental capabilities, and ecological suitability. If you don't want to watch a super long video, I would skip to physical characteristics and onward. If you have any questions about what it's going to be doing and how it does that, I would then refer back to the genetic contributors. Now, genomes. Our base genome is going to be the Orca. We're choosing the Orca because overall orcas are very capable predators. They are very adaptable. They're pretty much the perfect base for a hybrid that's going to be fighting other hybrids. Yeah, that's Orca. So, our next contributor is going to be the Curvier's beaked whale. The reason we're taking Curvier's beaked whale is they are very deep diving whale species. We're specifically taking the collapsible lungs, the flexible rib cage, and oxygen storage in the muscle tissue, alongside blood flow restrictions to control and the ability to control heart rate. The reason we're taking all these is collapsible lungs. One, when an animal dives, if they have air in their lungs, nitrogen will diffuse into the blood, and when they start to come back up again, they will the nitrogen will form tiny bubbles inside the blood, killing the animal. This is usually referred to as the bends. It's what happens if you dive too deep and swim up too fast. All animals can get it. Well, ones that breathe air, that is. And whales get around this as well as other diving animals by collapsing the lungs as they dive to extreme depths. We're taking this alongside flexible rib cage. As pressure increases, the water will flex the rib cage. If it is not flexible, it will snap under the pressure. Oxygen storage in muscle tissue. It's how whales store oxygen. They'll also store it in blood. However, we are taking the whale's muscle tissue oxygen storage, and the blood storage will be referred to later. Blood flow restrictions, basically non-essential functions, are shut down when the animal is diving, saves on oxygen. Heart rate control, also self-explanatory. Now, next animal, longfin pilot whale. Longfin pilot whales are basically smaller orcas. They're more specialized for hunting fish and cephalopods. How they do this? They dive down and they move really fast. This is in contrast to the Curvier's beaked whale. They can dive a lot longer than the short-fin pilot whale. However, the pilot whales, while they're diving, they are swimming at full speed, basically. The beaked whales do not. This adaptation helps us to maintain high speeds underwater while still maintaining a high level of duration. It's not going to be anywhere near a beaked whale if we're going to be swimming at top speeds. However, it's still good. We will also be taking the brain adaptations because pilot whales are way more social than orcas. They form larger pods, they're much closer knit communities, and they have exhibited cross-species communication and just overall very social animals. We'll be taking this to allow Nyx to exhibit cross-species socialization, basically, especially with other dolphin species. So, next contributor, Bottlenose dolphin. Similar reason to the pilot whale, they're also very social animals and have cross-species communication. Actually, also with pilot whales, mind you. But also sometimes humans and other dolphin species. Bottlenose dolphins are also considered one of, if not the most intelligent non-human animal in general. They have a higher brain-to-body ratio than chimpanzees. They exhibited tool use, bait and traps, very effective pack hunters as well. But the main real big thing that we're taking from these is their melon and ear structure. Bottlenose dolphins are capable of producing sounds of up to 150 kilohertz. This is outside the range of hearing of animals such as belugas, sperm whales, and orcas, meaning that this animal can continue to perform echolocation, and such animals, such as orcas, belugas, and sperm whales, cannot hear it in its echolocation, however, it can hear them. That means Vex cannot hear this animal if it chooses to produce frequencies of these ranges. Now, next animal, prehistoric whale species. I'm not going to bother with the name. Reason we're taking this, we're taking the skull pointiness and incisors and canines. The skull pointiness, I think it looks cooler. Also, makes the animal a bit more aerodynamic and effectively lets it open the mouth wider. It doesn't really, however, at the end of the mouth, the opening is wider. The angle of the mouth opening is not. Anyways, this species is similar weight class to large dolphins such as orcas and pilot whales. However, they do have adaptations suitable for ramming. So this pointed skull shouldn't compromise that really. But the real cool thing about these animals is their teeth. They had pointed forward incisors and canines that were likely used to ram and hunt larger prey animals. They're more specialized for hunting whales and such. We will want this because we want our hybrid to be able to hunt animals of similar or higher weight classes than it. They also in general, showed a lot of evidence of interspecies conflict, as they had lower tooth tusks, essentially, which is seen a lot in animals that fight with each other a lot. So this will just reinforce being able to fight things of a similar weight class. But again, these teeth, they might be suited for this, however, they're still well suited for gripping, piercing, and holding onto prey. And, added bonus, they have serrations. Orcas do not have this, causes more bleeding. Now, black marlin. This is a fish, not a whale. Our congruency so far has been pretty high. The reason we're adding black marlin, mucus production. Fish mucus can reduce drag on an animal up to 66% compared to dolphin skin of only being like 10 to 15%. So overall, it'll allow higher top speeds and increase efficiency. This actually increases dive times because the animal is spending less energy moving through the water than it normally would. However, I will note, whales don't have pores on the skin, so they wouldn't normally produce mucus. I will get to that later. Next animal, common octopus. We will be taking cephalotoxin. Cephalotoxin is a type of toxin produced by octopuses. This is used to kill crabs and mollusks. It is a poison because they shoot it into the gills of said crabs and mollusks. And now, this isn't good against mammals or like marine reptiles. However, I want this mixed into the mucus layer from the black marlin in low concentrations, and this will help prevent parasites such as whale lice on the hybrid. Now, next animal, Amazon giant leech. We'll be taking it for a type of anticoagulant compound that prevents blood clotting. We will be having this produced in a venom gland in the saliva. I will get into what gives us our venom gland later. However, basically no animals have natural resistance to this type of compound because there's no real selective pressure for it. I will get into later our animal that we're using to help resist its own venom, per se, heavy quotations marks. They're not really a venom. However, it is being used as one. Basically, though, this will, when Nyx bites something, it'll enter the wound and cause excessive bleeding. It's not going to be too crazy, however, it does give it an edge. Next animal, Midwater Squid. we want photophores. Photophores are basically little organs on the underside of the midwater squid that can produce light. The term is counter-illumination. Basically, it increases stealth, eliminates the animal's shadow, works better than just normal counter shading. It can also be used for communication and attracting prey. When Nyx is in deep water environments, bioluminescence can attract fish and squid. It can use this to its advantage to hunt more effectively, but also when it's fighting larger animals, it can be used as a distraction, turning into a disco light show. But also, generally speaking, if Nyx is above an animal and it is looking up at it, it will be much more invisible. Whales, and just a lot of animals in general, only have two-color vision, greens and blues, well, whales specifically, and this light produced is greens and blues. It can be adjusted based off light above the water, which is very cool that midwater squid can do this. But also, it can be turned on and off. So if Nyx doesn't want to produce light, it doesn't have to. Now, brief intermission. So, my hybrid does use semi-aquatic contributors. There's been a lot of debate on what these are. The dictionary definition is right there. If you want to pause the video and read it, you can. I'm on a time limit here, so I'm not going to do that here. But in the initial post, it said hybrids must only include sea creatures, no land animals, or flying creatures of any sorts, though you can use mostly aquatic creatures, example crabs, crocs, spinos, etc. And, added bonus, what has been allowed and not allowed. We have had the gaboon viper allowed in a hybrid before, and not allowed the polar bear. Now, here's a little graph I made of how aquatic some animals be. On the left side, you have more aquatic. On the right side, you have less aquatic, such as Arctic wolves and gaboon vipers, a terrestrial species of viper that lives near the Congo. So, yeah. Basically, the animals that I will be adding are roughly on the same level as platypuses, otters, penguins, hippos, and frogs. Some species of frogs are more aquatic, some are less aquatic. This is kind of a range. It's not a fixed thing. Spinosaurus are most likely in a similar range of wading birds and grizzly bears in terms of how aquatic they are. I've done a little bit of research into it, and it looks like they didn't really dive or anything, and they're definitely not sea creatures because they've only really been found in freshwater environments, brackish water at best, but never sea environments. This could be due to a multitude of reasons like salt tolerance. I don't know. I'm not a paleontologist. I mainly focus on living animals for my research. Anyways, the animals I'm including should be aquatic enough for this competition. So, I'll be getting into the first one. Extinct species of marine amphibian. So, we're using this animal for mucus glands on the skin. As we discussed earlier, I want black marlin mucus and mixed in cephalotoxin in the mucus. Amphibians have skin mucus glands that are distributed throughout the body. This is unlike animals like fish that will have like a few glands like behind the eyes that then coat the body. And we want something that can fit the whale's morphology. If it's distributed throughout the body, better for us. Now, next animal, southern elephant seal. We want this for oxygen storage in the blood. As I discussed earlier, this animal has specialized features to store oxygen in the muscle tissue. Elephant seals, unlike whales, specialize in storing oxygen in the blood. We'll be using this. We'll have specialized adaptations for storing oxygen in both muscle tissue and blood. The reasoning behind this is they basically went to two different evolutionary pathways to get the same result, well, roughly equivalent result. We'll be taking the end result of both of those and combining those for a better one overall. So, leopard seal, next animal. We want reversal of sexual dimorphism in the orca. Basically, female orcas are traditionally smaller than male orcas. Leopard seals, it is the opposite. We'll be taking that feature, so Nyx is the upper size limits of male orcas. The reasoning behind this, we want it to have female behavior, male physical capabilities. Now, also, we want the molars of leopard seals. Leopard seals have molars that are specialized for, filter feeding, basically. They still are capable of hunting seals and penguins. However, their back molars can filter feed shrimp and Arctic krill, which is very helpful. They're very plentiful things, and if our hybrid can do that, it can survive in more environments more effectively. Now, next animal, Eurasian water shrew. Now, this might be debated whether this is aquatic or enough or not. However, I would point your attention to the gaboon viper, a terrestrial snake. Now, what are we adding from this? We want iron in the enamel and venom glands. In the saliva, that is. I'm sure you've already heard this in the Indom video. Iron teeth, stronger than normal. Our teeth aren't particularly suited, especially the molars, to high bite forces. This will help that, essentially. This animal already will have a bite force slightly lower than orcas, partially due to the longer jaw. However, this helps it not shatter its teeth or anything. Now, also, venom glands. We want it to secrete the anticoagulant compound in its bite. We're using the venom glands and then modifying the venom glands to produce that compound. We're not using the Shrew's neurotoxin here. Then the injection method is just the animal bites it and then they get the compound in their blood. Now, water opossum. Next animal, same deal as a shrew. I would like to point your attention to the gaboon viper. What we want from this, toxin resistance and in particular anticoagulant resistance. Opossums in general are very resistant to snake venoms. Snake venoms in their areas have anticoagulant properties. And basically we want this so our animal doesn't accidentally cut itself in the mouth, let's say, and bleed out. It probably wouldn't do that. However, I'm paranoid and I like over-engineering things, so I'm adding this animal. If, for whatever reason, you don't think this is aquatic enough of a species to add, I can take it out and it doesn't really do much to the hybrid. Now, next animal, ornate Nile monitor. Type species of monitor lizard with very similar to crocodiles. Now, what we want from this, we want continuous tooth replacement and parthenogenesis. Anyways, reptiles in general have the ability to replace teeth over time. They do this kind of like crocodiles and sharks. Mammals do not. We want this trait, so if our hybrid's teeth get damaged for whatever reason, they can be replaced and it's always in top condition. Now, we also want parthenogenesis. Mammals traditionally do not have this trait. However, there has been rare cases in humans where there has been errors in how the eggs are fertilized, and the egg will duplicate the X chromosome to compensate, per se. And then the child will have more of the mother's DNA in them. Anyways, we will be using the Nile monitor as a basis for this trait. Granted, you could probably get this done better with just traditional gene editing. However, we need to add contributors for every trait we're adding, so we're adding it this. Now, Nyx will not be fighting Vex in a pod. However, I just like adding this trait because it's that funner this way for me. I mean, if you want to do a pod versus pod battle, that's fine. However, not good for you because we can handle larger pods than Vex can. Anyways, physical characteristics. This is the good part. So, Nyx is going to be 36 feet long, 11 meters, and going to weigh 11 tons. This is the upper limit of killer whales, generally speaking, the males at least. This is a artwork that I have made of Nyx. It is basically just a killer whale with shorter fins and its longer face. That's all it is, really. And, oh yeah, photophores on the underside. So, combat capabilities. This is what we care about, right? So, speed. In short bursts on the surface, Nyx can most likely hit speeds of 35 to 40 miles per hour. When it is 200 meters or deeper, it can most likely hit 50 miles an hour. Maximum best case scenario. Now, I will explain why I believe this. First of all, we have drag reduction from the black marlin. Second of all, we are using pilot whale and dolphin DNA in the hybrid. Dolphins have been reported to hit speeds of roughly 37 miles an hour on the surface. They never really get higher than that. And the reason behind that is cavitation. When a large animal starts to move very quickly on the surface of the water, little tiny bubbles will form on the surface. This also happens to boat propellers. But same thing that mantis shrimp actually use in terms of punching. But basically, these little bubbles will form on an animal when they start hitting speeds of higher than 35 miles an hour, and they'll collapse and cause extreme damage to the surface of the skin. This is mainly focused on the fins and the tail. So, the main reasoning for the pilot whale is to help increase speed there. And the mucus covering should prevent it a little. This hybrid on the surface can't really go any faster. When it's deeper than 200 meters, however, it can. The reasoning behind this is the muscular anatomy of animals like killer whales most likely allows for higher speeds. However, cavitation is the main limiter because it hurts the animal a lot to go faster than that. So, when it's at these depths or deeper, cavitation, due to the pressure of the water, cavitation is a lot harder to occur. And due to all of our oxygen adaptations, the animal can dive for longer periods and maintain higher activities for longer periods, allowing it to hit these speeds at all. Cruising speed is roughly 4.9 to 7.9 miles an hour. This is just by virtue of the animal having better drag management than a traditional whale. In terms of defensiveness, it's just normal orca skin thickness and blubber. It is very good. It has been tried and true and tested by orcas for thousands of years. No reason to really change it without compromising anything, so I'm not gonna. Bite force is at around 15,000 psi or 65,000 newtons. This is a bit lower than what an orca traditionally would be, just due to the mouth being longer and the teeth not being as optimized for bite force. Ramming force, however, is basically like if it hit it, a semi-truck is running into you. Due to the animal's weight and speed, that just makes a ton of force. Orcas ram really hard normally. This is basically just a faster orca in terms of ramming, so it does more damage. That's about it. The ramming force is higher than basically a Cybertruck hurtling down the highway at 70 miles an hour, or however fast they go now, I forget. But it's between a Cybertruck and a semi-truck collision, essentially, in terms of force, if you want a reference there. Now, special traits. Saliva. Nyx produces an anticoagulant that acts very quickly. When it rams into something with its forward-facing teeth, it'll cause wounds. Alongside its saliva getting into said wound, or if it bites you, the wound will bleed more and faster, causing catastrophic blood loss, and then reducing your capability to fight. Nyx also has a mucus that contains cephalotoxin. This primarily is used to kill small parasitic invertebrates such as crustaceans and clams, but most likely works on worms as well. Nyx also has bioluminescence. This helps hide Nyx from sight-based animals. It reduces her shadow. It makes her harder to spot. especially at the surface. Nyx also has echolocation of frequencies of 150 kilohertz. This means any animal that doesn't have the special ear bones suitable for hearing this, basically only from the harbor porpoise and a few smaller dolphin species, won't be able to hear Nyx, and Nyx will be able to hear you, meaning it is basically invisible on sonar. Now, mental capabilities. Nyx is slightly smarter than a Orca and is capable of cooperating with other species very effectively. That's about all Nyx does. In terms of like extra mental capabilities, not much more to say there. It can be trained by humans, other dolphin species, so it can learn more skills from a broader wide of animals. Ecological suitability. So, prey. It can eat fish, cephalopods, mammals, seabirds, marine reptiles, krill, and shrimp. It basically can eat anything that it wants. It wouldn't eat anything too small because why would it bother? Its range, same as the Orca. I used Orca. I made an Orca that's slightly better. That's what I did. Dive range. It's a bit less than the beaked whale. I said a bit less because it's not... I don't know. It's not like a perfect beaked whale in terms of diving, just like... But it still can dive extremely deep, mind you. Caloric intake is about 500,000 kilocalories. This is in line with a large orca. However, it is slightly larger due to the production of mucus and anticoagulant toxins. However, this is not unrealistic to feed the animal if it is feeding off things like seals, penguins, sharks, whales, etc. Predators, it would have no natural predators. Dive duration, if it is at high activity, it would likely be 15 to 30 minutes, similar to a pilot whale, however, slightly shorter because it is larger, mind you, like significantly larger than a pilot whale. However, it does have all the oxygen adaptations, so 15 to 30 minutes is pretty fair. If it's at low activity, though, it could probably push hour and a half, 2 hours in terms of just dive duration. Now, ecological suitability. It probably outcompetes orcas in a lot of ways. It has parthenogenesis, so over time it would slowly replace orcas, basically. It could also potentially outcompete toothed whales, such as pilot whales, beaked whales, and sperm whales, causing their extinction. It wouldn't do much more than that, but that's kind of what it would do. Now, this is the thank you slide. I used a template from a website, and they need me to include this slide, so here it is. If you have any questions, just find me on YouTube or Discord. I don't know, just... I don't really care if you ping me or anything, just, have fun with that. Anyways, bye.